Chemical properties of group 14 elements. Action of oxygen. Action of oxygen. When heated with oxygen, they form monoxides and dioxide. Heated with oxygen. Form monoxides and dioxides. Okay. So, here silicon monoxide exists only at very high temperature. And in this case of oxides having higher oxidation state are more acidic than oxidation state of lower oxidation state. Okay. Higher oxidation state dioxides are more acidic. Okay. They are more acidic than lower oxidation state. In the case of dioxide, for example, carbon dioxide. Carbon dioxide is acidic, then silicon dioxide and germanium dioxide. These are acidic in nature, whereas SnO2 and PbO2, these are amphoteric. What about their monoxides? Carbon monoxide is neutral. Carbon monoxide neutral. Then germanium oxide, which is acidic in nature. Okay. Whereas tin monoxide and lead monoxide, these two are amphoteric. Amphoteric in nature. Okay. Next, action of water. Carbon, silicon and germanium. These three are not affected by water. Not affected by water. Okay. Whereas in the case of tin decomposes with steam. That is, tin on reaction with water, that is reaction with steam, it forms SnO2 and hydrogen gas is evolved. Whereas in the case of lead forms an oxide coating on its surface. So it does not react with water. Okay. It is unreactive due to protective oxide film on its surface. Next, action of halogens. This group form two types of halogens, MX4 and MX2. Okay, X represents fluorine, chlorine, bromine and iodine. Okay, most MX4 compounds are covalent. MX4 are covalent, but SnF4 and PbF4, these are ionic. And we know down the group +2 oxidation state increases. Okay, that means their oxidizing power decreases or their reducing power increases. Okay, and what about their thermal stability? Thermal stability in the case of MX4 compounds. Thermal stability means they can't break even at very high temperature. Okay, we know thermal stability decreases down the group. So the order will be like this: CX4. Okay, SiX4. Thermal stability is more for carbon, CX4. Okay, then GeX4. then like this. This will be the order of thermal stability. Okay. Also, if we take carbon compounds only, CF4 is more stable, then CCl4, then CBr4, then CI4 is less thermal stable. Thermal stability is less in the case of CI4. Okay, because the size increases, what happens to their polarity? Their polarity decreases and their thermal stability also decreases. Now, in this case of this MX4 compounds, their hybridization is sp3 hybridized. These compounds are sp3 hybridized. Okay, they are sp3 hybridized. They are non-polar. Okay, and regular shape is, geometry is regular tetrahedron. Okay. Next, in the case of PbI4, it is not at all stable because I minus is a strong reducing power. Okay, I minus having more reducing. It is having more reducing power. Okay, so what happens? It reduces plus 4 state to plus 2. So it reduces this. So PbI4 is not at all stable. Also we know down the group plus 2 oxidation state is more stable. So PbI4 is less stable. Next, in the case of germanium and lead. Germanium and lead, they also form MX2 compounds. In the case of MX2 compounds, the stability increases down the group. Okay, so if we take GeX2 and GeX4, in this case GeX4 is more stable than GeX2. But if we take PbX2 and PbX4, PbX2 is more stable than PbX4. Okay. Next, hydrolysis of halides. Hydrolysis of halides. In the case of CCl4, we know carbon contains no d orbitals. Okay. So, due to this unavailability of d orbitals, CCl4 does not hydrolyzed by water. But other members are hydrolyzed. Hydrolyze due to d orbitals. So, due to these d orbitals, they can accept the electrons from the, that is lone pair of electrons present in oxygen. They can accept those lone pair of electrons and hydrolyzed with water. Okay. For example, in the case of SiCl4, Si, this will be the compound. Okay. With water, what happens? It contains lone pair of electrons. Okay. Silicon accepts those lone pair and minus HCl is removed. So it is replaced by OH. Okay. SiCl OH. So this compound is obtained. Okay. Again with water, 3H2O, 3HCl is removed and form SiOH 4 times. It forms SiOH 4 times. And this compound is called as silicic acid. Silicic acid. This compound is obtained. Next, what happens with SiF4? On reaction with SiF4, what happens? On hydrolysis, it gets converted into SiO2. Okay, silicon dioxide, that is silica is obtained, and 2H2 SiF6. 2H2 SiF6 is, this compound is called as fluorosilicic acid. Is obtained.